volevo sapere se era possibile qual è la durata del ciclo orbitale e la distanza massima e minima dal nostro pianeta del satellite.
Okay, I can't remember actually. I mean, I'm actually not sure what the period of the orbit around L2 is. And at some level, since we're always doing orbital maintenance, the orbit changes every time we do an upgrade to the orbit. So the telescope's always 1.5 million kilometers from Earth, and it's actually orbiting the L2 point. So it never goes higher than about 500,000 kilometers above or below that point, and it never goes further away from that point than about 800,000 kilometers. And we have those limits because as it goes around this L2 point, 1.5 million kilometers away from Earth, we want to minimize the amount of time that it can see those bright infrared sources, the Earth and the Moon, which will contribute stray light to will scatter off of the telescope. So that's why we set those like that.
Dall'altra sala.
Okay, let me start by just saying I'm not really sure that what the timescale for putting a telescope on the moon will be right now. I mean, there is a program that NASA has to return to the moon and start doing work on the moon, but there's no set timetable yet for things like trying to start doing science on the moon. As far as the benefits of having a telescope on the moon, I think it depends what you're doing. So for a telescope like JWST, there's a big debate that it may not be a good idea to put it on the moon because there's a lot of problems with moon dust, and you can actually contaminate both your instrument and the telescope optics with dust very easily, which would severely hamper its ability to do science programs. I think right now people think the best kind of astronomical science you could do from the moon would be radio observations, and there's a number of ideas out there about how you would do that, and people are doing small studies, but there's no real time frame for when we would actually try to do that right now.
Purtroppo il tempo corre e abbiamo soltanto la possibilità di un'estrema ultima domanda. Prego.
Sì, volevo sapere se dopo il James Webb Space Telescope c'è una roadmap per altre generazioni di grandi telescopi spaziali e come saranno? Cioè, lavoreranno nell'infrarosso con specchi più grandi o cosa? Grazie.
Okay, sorry, my translation keeps popping in and out here. I think the question was, what could we do with a larger telescope? Okay, so in the infrared, the next thing that people are thinking about doing is going to longer wavelengths with a larger telescope, and there's a number of concepts out there that actually look very similar to James Webb. It's just that the mirrors are much larger. People talk about 10 to 15 meters, and this telescope would work from about 10 microns to 100, or a couple of hundred. There's also a number of concepts out there for a super Hubble, which would have an 8 or a 16 meter mirror, and people are looking at how you could actually basically make something that was affordable. I mean, the problem with all of these telescopes as they get larger and larger is they need more and more new technologies, and you have to start being very innovative in how you think about implementing those technologies so you can actually, A, afford them, and B, you have a way of getting them into space. So there's a number of mission studies, for instance, going on at NASA now called the Strategic Mission Studies, and they're all looking at optical telescopes in the region of 8 to 16 meters, and these would both be general facilities like the Hubble, and they would also have more focused science like trying to image terrestrial planets. But again, these are just concept studies, and we have a process in the United States that's just starting that happens in astronomy every decade, and it's called the Astronomy Decadal Panel. So the National Academy of the United States every decade convenes a panel, and they then convene sub-panels in all the different areas of astronomy, and those people meet, they hear evidence from various groups, and they put together a plan for the next decade which has a set of prioritized goals. And that pretty much is used by NASA as its roadmap for what it should spend its money on next. So these strategic mission studies looking at these larger telescopes are all just finishing up right now, and they will be reporting to the decadal panel that's being formed right now, and then they will make the recommendation for what to do next. And I think it's fair to say the three competing ideas, or at least two of the ideas for what kind of science people would do. There's a mission called LISA, which is a joint US-European gravitational wave experiment. There's a mission, used to be called CONNEX, and I think in Europe it's called ZEUS, that's been combined into one international partnership, and they're looking for a new super X-ray telescope. And then there are a number of ideas about large telescopes that would look for planets by either directly imaging them or doing astrometric measurements to detect them down to the size of planets like our own Earth.
Bene, purtroppo siamo arrivati alla fine e non ci resta che ringraziare Mark Clampin e augurargli un in bocca al lupo per la sua avventura.
Anch'io ringrazio innanzitutto Giovanni Caprara per la usuale, puntuale precisione scientifica e chiarezza, e Mark Clampin che nella sua esemplare professionalità ci ha fatto anche la cortesia di tradurre la maggior parte delle diapositive in italiano. Grazie. Vi chiederei di lasciare, allora, come già comunicato, la conferenza successiva non sarà quella prevista nel programma con l'astronauta Tereskova, che per ora è sospesa. Avremo il professor Di Freddi con una conferenza dal titolo L'evoluzionismo e matematica. Vi chiederei però di lasciare la sala perché dovremo fare la procedura di ingresso, perché c'è già una lunga fila d'attesa fuori. Grazie.
Thank you, Mark. So was that okay?
Yes.
Okay, good.